Hello. In last lecture, we discussed services and protocols view, and we said study of computer networks is primarily focused on understanding how different protocol works. From services view is the applications that runs on edge systems, and at the edge systems we make requests, get messages, packets flows in the network. So let's study the structure of how the edge network works and how they are connected and what is involved. The next lecture will look at the basic core part of it before delving into the actual communication and protocol issues. So as we said earlier, if you look at our network, the edge systems consist of home network, the office network, or mobile users. They are the edge networks and connected by access links. Is connected to, which typically could be DSL, satellite, 3G, 4G, depending upon how your things are. So let's look at what the network edge is. We said edge always consists of clients and servers. Clients are the people who make use of services like end users. We use our browsers or email client or something. We use PCs, desktop, iPad, iPhones, and their servers. Now, servers are typically in the data center. Today, what we call is cloud. The external network is connected by the physical media, which could be either wire link by laying a physical dedicated wire. If you're in the office, we're connected by Ethernet, or with access network, it could be either wireless as well. So it could be wireless link, microwave link, or 4G link, or we could have a fiber link, which is what you see both kind of links. At the core, we have interconnected routers. These are the routers which are connected, that are typically connected by high speed, high gigabit bandwidth network, and we have a network of network. So traditionally, our end system used to be PCs. That when the network started, in fact, used to fix to the desktop that we used to use. Then in mobility, laptop came in. But today, internet is available, plethora of devices, Google glasses, probably not taken up that much, gaming consoles, TVs, entertainment systems. You look at and every is available. Picture frames. I have a picture frame in my house, and like sling box, and I put somewhere, send a picture, and I can see it directly at my house. We have all kind of IT devices, wearable devices, sensors. We have forest sensors, animal sensor roaming around. We have to do the counting and look at various applications in scenarios. If I need to count the wildlife habitats, we probably insert a chip and figure out how the animal movement happens to look at their normal behavior, predicting behavior, eating, roaming around, typical life cycle of an animal in a wild forest. We do that. And now we have devices called Fitbits, and which basically falls into what we call is body area networks. And then, as we said, we already seen iWatch, like Apple's iWatch or other smart watches, which measures your BP, your heartbeat, your other stuff, health bands, and so on and so forth. Now, how these things are connected? Let's look at our edge systems, that's either office or home. So first look at our residential network, which is connected by the typically, if you are in home residence, you're typically using DSL network, or if you are using carriers like Idea, Vodafone, or Airtel, you're probably using 3G network, which is wireless connectivity. So, but when we access our link, if you are at home using DSL, we basically choose our plan that do you want a 2 Mbps link or 4 Mbps, 20 Mbps. The carriers there who are have a fiber connectivity, you even get now 24 Mbps, 40 Mbps, which was unthinkable a few years ago. Now you can get at the very high rate of 40, 50, even 100 Mbps connectivity. Other is when you look at the office networks, typically when you take DSL network or the lease line is typically shared, what we say 1:4. That means even though say they give you 10 Mbps peak connectivity, that means 4 people or 10 people may be sharing it. So on the shared network, if one dedicated connectivity 1:1, and cost could be going very high too. Now, the home connectivity, we probably know the home connectivity, we look at a dial-up. Dial-up, it used to be there about 10 years ago. You probably, it become historical purpose, you don't find them anymore because everybody got 3G or 4G connectivity. So dial-up practically died its own death. Most of the houses are connected by DSL, called digital subscriber link. We'll study a bit later. In European and first, we also have cable net, which is not seen in India. Only for remote places where you can't have a cable or a phone and the 3G, 4G doesn't work, we probably can depend upon satellite. But now everybody wants very, very high bandwidth. We're interested in watching movies, like cricket game and so on. So we need high bandwidth, which probably is served by the fiber. And so government is laying the whole fiber network across the country called BharatNet, the fiber to the home, and of course our mobile. Now we see current news, 5G is in the offering in the pipeline. With 5G, probably the bandwidth go much, much higher. Now also look at, previously we used to have what is called fundamental access. We used to think so-called roti, kapda or makan, they basically food, clothes to wear, place to live, and now one more become fundamental right, internet access. In fact, few countries like Spain and Finland is even a fundamental right that you can demand from the government, they're bound to give you. The broadband access varies from country to country. In India, I believe still the definition is as long as you get 256 kbps per second, you can call it a broadband. But most of the country it has become tons of megabits per second. Let's look at how the DSL work. At the DSL, you have a house. House is connected via telephone line to what is called a DSLAM, digital subscriber line access module. We're connected to it. We use the same phone line on which the phone line is connected, and which the phone line carries both voice and data at the same time, but they carry at the different frequency range, so they don't interfere. If you're using a dial-up, your data used to use the same bandwidth, but the same frequency channel which were used for voice call. That was the reason. If you are using a dial-up, you can't use internet or voice at the same time. But with DSL, both can be done at the same time because voice frequency is in a different range. Voice frequency lies in the range of less than 4 kilohertz, whereas data access goes from 10 kilohertz to higher up 4 to 50 kilohertz. And DSL is typically called asymmetric. Asymmetric means your upload, that is the data you're trying to upload, is probably a much lower rate than data you download. So DSL today you get up to 20, 24, even 40 Mbps, but the upload still is 1 megabit too. So if you look, when you're downloading or watching a movie, it's much faster. But if you create a movie yourself, or let's say HD quality movie and want to upload, watching a movie, if it takes you, let's say 10-minute movie, if you download, or it will take you, not sorry, if you download 1 gigabit movie, it will probably take you a few minutes, but to same upload 1 gigabit size movie, it might take you 10, 20, 30 minutes because upload speed is about 10 times slower than the download, and that's what they give. Of course, there's a symmetric DSL, but that is very rarely available unless for a cost per subscriber, cost may become too high. And as you said, my upload is still limited to maybe 1 or 2 Mbps, where a download has gone to 10, 20, 30. By standard wise, is 55 Mbps. Other access network is called cable network technology, which is very rarely you'll find in India. It's available in Europe and US. In fact, I had cable access for a quite long time. So my cable used to give me a phone line, it used to give me internet, it also gave me the TV. I used to get all three from my cable network and it works fine. And cable is a shared network, it follows a particular standard. You probably have a cable modem at the end to the ISP. At home, you have a cable modem, and it is the your cable, which is your cable network wire, the coaxial cable serves the access media, and typically this will be shared between about 200 to 250 households. Beyond that, they probably will do a splitter and give you different connectivity. You have something called the hybrid box, because from CMTSN there will be fiber connectivity give you, and now the access happens. And again a asymmetric access, and the cable network follows the standard called DOCSIS. Since we don't study it in India, we're probably not going to do much more. Even as part of our network course, it's good to know these details, but most of the focus would be looking at the protocol, how do we, the S systems and the routers talk to each other. Next is what is predominantly happening now is fiber to the home. That means now everyone should get much higher bandwidth, and rural net we are laying the fibers, and that means everyone probably will be able to access network at the rate of gigabits and not even few megabits. And again, there are two kinds of connectivity, what is called active optical networks or passive optical networks. It was more like Ethernet hub, which is the switched or the hub repeater. Will probably look at when you study at the link layer devices, probably towards the end of the course. So look at the access net, how to get connected. At the access network, your DSL line, you have a DSL modem, you have a router, and you probably connect via Wi-Fi, three different devices. But today, technology is advanced, and all these three things, your DSL modem, your router, and Wi-Fi, all gets combined into a single box. So you don't get three different boxes, you get single box and connected. So you have a wired PC connected, you have a phone connected to it, you have a laptop connected to it, and which is on the DSL network or connected to the carrier like Airtel or others, and you get the access. If you're in office or a college or university, the whole college network, you have a libraries, your lab, department, faculty connected by a wired cable Ethernet, which is typically 100 Mbps. Of course, each colleges now give you Wi-Fi connectivity, so you can use phone or laptop, sit anywhere, you don't have to be in the lab. And college typically would have one main access router, and for each lab, there will be sub routers connected, and that's how the college network would work. Typical college network connectivity, as I said, is 100 Mbps, and upstream connectivity is probably 50 to 100, but few labs you'll still may find in gigabit connectivity. In India, probably we still don't have a 10 Gbps Ethernet, but in advanced countries, you may find enterprise network giving you 10 gigabit connectivity to run applications there. And now wireless access, we probably follow only two 802.11 system there. So mostly what we are today is using 802.11n, but the standards already available called 802.11 A, C, and D. BG used to give you 1151 Mbps, 11n gives you about 100 to 300, AC gives you 500 Mbps. When you're looking at Wi-Fi, AD giving you 1 gigabit access. So Wi-Fi network is evolving, and we also have the remote connectivity. When you use 3G, 4G, 3G was an Mbps, 2G probably give you few kilobits access, and with advent of 5G, you probably get even 100 Mbps or even more of connectivity. How these are connected? We typically, if it's a wireless, we have a microwave, but wire link on Ethernet, typically what is called a twisted pair copper wire. That means two copper wire connected in a twisted way to provide the interference. Your coaxial cable for cable network, fiber optic, again we have to find the single mode fiber or multi mode fiber. We have satellite link, which you don't use, terrestrial radio, those kind of connectivity. When you look at the cable, it could be guided media or unguided media. Guided media means my signal travels along the wire, which is physical cable. Unguided media, there's no physical wire, so it is a line of directions like microwave, but following the unguided media. 3G would be unguided media. So any radio access would be unguided. All the wired access would be guided media. Perception of wired media is cost is high. Actually, it is far from the truth. The cost of the cable is very low. If you buy a UTP cable or the Ethernet cable, it probably costs you 5 rupees per meter, but cost of laying is way too high. It probably varies from 30 rupees, 50 rupees per meter, 100 rupees per meter, depending upon how the duct has to be laid, the laying has to be done. So cost of laying the cable is a lot more than cost of the actual wired media. We also have, they said, physical media. The first thing we use the Ethernet wire. It has about 4 pairs of wires which we provide using Ethernet, and it is typically unshielded, meaning so two categories called shielded twisted pair and unshielded twisted pair. Shielded twisted pair, the 4 pairs of wires will be covered by a wire mesh. It will be strengthened, and so that anything happens will not be broken, it will protect it. Unshielded means you only have a plastic shield. So if you take a normal RJ45 cable, which you connect to the laptop, if you cut it open, you will just see 4 pairs of wires, and that is unshielded. Initially, it used to give only 10 Mbps connectivity. Now this gives you even gigabit. They are very, very shielded twisted pair may give you 10 gigabit connectivity, but mostly for high bandwidth we use fiber optical cables there. They gives us, and in fiber optical, one pulse corresponds to 1 bit, and we have very, very high bandwidth. The good part about fiber cable, it is immune to electromagnetic interference, and further, since there is no copper there, if somebody breaks the cable, steals it, it has no market value. If I'm laying a copper cable, it still has a market value. It's a copper. People steal the copper wire, the whole thing, melt it and sell it as a copper. But fiber, the cost is not in the fiber cable. Cost of fiber comes in the laying. It needs specialized equipment and the connected systems that makes our cost optical connectivity. And the transmitter receivers, that's the cost, but those are laying down, and that's where my cost comes in. So in summary, in my access network, we looked at the S systems, which is my laptop, PCs, phones. At the server side, we lies in data centers. Then look at access links, which are basically my the DSL cable. I also have the fiber, and we have in the home within network, we have Wi-Fi connectivity, Ethernet connectivity, and we briefly reviews twisted pair as the way we connect Ethernet and fiber cable, and that's the way we work. In next lecture, we'll look at the core networks, how they're connected, and then we go into actual networking protocol.